Very good morning. We are coming from Group C6 and I'm about to present about trade riot on the production of potato chips. Me myself, Kirenraj, and my other members, Didar Dadebayev, Goh Aik Wai, and Jaspreet. So I'll begin with the drying part. So introduction before we begin. So drying of food is carried out because microorganisms which cause food spoilage and decay are unable to grow and multiply in the absence of sufficient water, and many enzymes which promote undesired changes in the chemical composition of the food cannot function without water. And secondly, dry foods are easy to transport and store because they occupy only 1/10 the volume of the fresh food. And last but not least, dried foods are most suitable for handling. Also outlined that dry foods involve the removal of water from foodstuff. In most cases, drying is accomplished by vaporizing the water that is contained in the food. And to do this, the latent vaporization of heat must be supplied. So, the two important process controlling factors. One, the factors that enter into the unit operation of drying, they include a transfer of heat to provide the necessary latent heat of vaporization, and also movement of water or movement of water vapor through the food material, and then away from it, effect of separation from the food material. And this statement was actually cited by Claus and Hans in 1995, Andres 1999, and Movers 2003. Next, the equipment used in this industry would be tray dryer, and therefore it is ours too. And this equipment is widely used in the food industry to replace the traditional method of drying. So in the laboratory, the equipment comprises of an air duct mounted on a floor standing frame to give a comfortable working height for the operator. So air is drawn through the mesh guard by a motor-driven axial flow and fan impeller whose speed can be controlled to produce a range of air velocities in the duct. And in this experiment, our main objectives are effects of air temperature and the effects of air velocity. And lastly, the industry that we have chosen is the production of potato chips. Reason being, production of potato chips involves drying and also tray dryer, which actually suits the research that we are working on. Thank you. Right, so my name is Kiran. So this time I'll be presenting about the customer requirement. So in the rice-based food system of Southeast Asia, the Irish potato was largely known or a novelty food amongst the indigenous population until only a few decades ago. So while per capita potato consumption is relatively small by international standards, both fresh table potatoes and processed potato products, especially potato fries and chips, are become increasingly popular in the region. So children, teenagers and young people are the target market of the potato chips line. Home rather than school is the most popular destination for eating crisps and savory snacks. Against around half, 48%, with 7 in 10 children, 70%, who eat such snacks at school. And after school, when children tend to choose their own snacks, 70% selects crisps and savory snacks compared to lunch boxes which mother generally pack, where the most popular item is a savory sandwich or roll. Some 44% of consumers prefer to buy children's snacks in multitask, while nearly half of all consumers say they are price motivated in their snacks purchasing. And the targeted customer in this potato chips industry is more of a children, teenager and also young people. And if you could see the market mix, where most come between the age of 11 to 20, followed by age of 5 to 10, and a small age between 21 and above. And the demand of present market is met by the mix of branded and unbranded chips available in the market. There is a 60% of the population which is brand loyal. However, remaining 40% of the unbranded market can be attracted through heavy advertisement campaign. And the analysis as follows. You could see here the branded is 60% while the unbranded is 40%. Right, thank you.
Hi, I'm Kah Wai from Group C6. Now I would like to describe the process of making potato chips in our plant. So I will use flowchart to explain every steps in the process. So as you see, the raw potato will undergo washing, peeling, slicing, washing again, blanching, drying, frying, sorting, flavoring, packaging, and to become potato chips. So in this slide, I will use process flow diagram to describe every steps in the process. So at the beginning, the raw potato will enter the washing machines, and the potatoes before entering the washing machines are emptied into the hoppers. From decayed tubers, stones, and trash are being removed. Then the potatoes are elevated into the washing machines. And after entering the washing machines, the potatoes will enter the peeling machines. So the potatoes are being peeled and then rinsed and passed over inspection belt for trimming and removal of decayed portions. And after the peeling machines, the potatoes will entering the slicing machines. So the potatoes pass through a revolving that cut them into the paper thin slices. So the potato slices will entering again into a washing machines. So the slices are washed in a rotating reels with jets of water under pressure. And then the potato slices will enter in the blanching machines. So the continuous blanching system here features cross-circulation water bath to ensure even blanching for each slices. So the blanched slices will enter the tray dryer. So the blanched slices are channeled into the dryer to lower the moisture content of the potato slices. So after the drying, the potato will enter the frying machine for frying. So after frying, the crispy potato chips are ready for inspection to ensure their quality. There is shorter to scan defects and tonal variation like black spots or green spots on the potato chips. So after the sorting process, the potato chips will enter the flavoring process. So in this process, the potato chips were flavored by a variety of coating and seasoning powder using rotating drums. So after this, these potatoes are ready to be packaged and ready for sales. That's all of my part. Thank you.
Hi, I'm Goh Aik Wei from Group C6, and I'll present to you all the equipments used in the production of potato chips. So potato arrive in the factory in big scale, which is in container. To transfer the potato from conveyor into the warehouse, we use a giant lift which elevates the container into a certain angle so that the potato can be rolled off into the warehouse. Inside the warehouse, we use air conditioner so that we kept the temperature in the warehouse at constant to preserve the potato much longer. From the warehouse, we need to transfer the potato out to the production site. We will be using conveyor which vibrates a little bit so that the soils, stones will be, can be shaken off during this process. Moving on is the washing machine. Washing machine is one big cylinder, spinning cylinder, and it consists of water pump. The pump will pump the water at high pressure, shooting at the potato, so that the soil remaining at the potato will be moved. Besides that, you can see that the spinning cylinder consists of tiny holes. This allows the soil to be removed, but the potato will move on to the next section. Next section is the peeling machine. The peeling machine consists of many rollers which revolve at certain speed so that the potato skin can be removed evenly. And next is the slicing machine. Slicing machine consists of blades which cuts the potato into very thin, such as
as thin as paper. Moving on is the washing machine. This washing machine is to wash off the starch which produced when we slice the potato. So at this washing machine, the equipment involved is water pump, which pump the water to wash the potato. Secondly is the level controller, so that the water level will not overflow. After this washing machine, we will move it to the blanching machine, which controls the minerals, color, and pH. And in this machine, we have this pH and mineral sensor to detect the level of pH and mineral contents in the solution. Besides that, we have the level controller so that it will not overflow. Moving on is tray dryer. Tray dryer is the most important part of this session. So why do we use tray dryer instead of another dryer? Because to produce potato chips, we want the potato to be in the shape. Tray dryer will not destroy the shape of the potato chips. So the equipment involved in tray dryer is the sensor, which senses the temperature and humidity inside the tray dryer. Secondly is the heater to produce heat in the tray dryer. Why? It is because if we produce more heat, the evaporation will be faster and drying process will be faster. And the next one is fan and blower. This is provide the tray dryer to have the constant speed of air so that it will make the drying process faster. And the next is the frying machine. This is to cook the potato chips, and the equipment involved is sensor again. It is to measure the oil temperature. And next we have heater to heat up the oil to certain temperature. And we have oil filter to filter the oil. Next, we have salting and flavoring. This is to give the taste at the potato chips. So we have salter and seasoning to give it the flavor. And next, we put this into a rotating drum so that the seasoning can be evenly spread at the potato chips. Next, the potato chips is being moved into this sorting machine. This is an example of a metal detector to detect any foreign particles such as metal, and it is one of the QC, important QC in production of potato chips. Moving on is the packaging. To have this, we have this weighing scale so that the potato chips can be filled up to the required weight, and we have this heater to seal up the top and the bottom part of the potato chips. So there you are, this is Lay's potato chips. Thank you.
Hello everyone, I'm Deck Yik from Group C6, and I will continue on explaining the separation process unit in our experiment, which are the tray dryer. Tray dryer is actually important in our process of production of potato chips, which explained just now. The main purpose of tray dryer in the experiment that we conducted is to remove the moisture content of the wet sand. The objective of this experiment is actually, there's two, which is the first one is the influence of air temperature at constant velocity of air, and the influence of air velocity at the fixed temperature and humidity, which will affect the drying rate of the wet solid. The result that we got from the experiment is actually the higher the heater power and the higher the air velocity, the higher the drying rate, and the time taken for the drying for the product is a lot more shorter. However, the optimum values for both heater power and air velocity is actually can be determined through this experiment. Generally, there's many types of tray dryer. Main of it, there's the raw materials used for the tray dryer is needed to be spread out and needed to be thinly in the process. But however, there's few types of heating system different from the tray dryer, which the first one is the air current sweeping across the trays, conduction from the heated trays, heated shelves on which the tray lie, the radiation from the heated surface. The experiment that we have conducted, which is the tray dryer, which is using actually the heating through by air current sweeping across the tray. On the production of potato chips, tray dryer is the main components in it. The tray dryer is used after the process of washing and color minerals treatments and before the frying process begins. It is very important on the process because as it can remove most of the moisture content so that the frying process later on can be eased. The tray dryer used in this production is an enclosed insulated housing in which trays are placed on an angle rack. Heat transfer is direct from the electric heaters of the tray dryer, and a designed air circulation fan arrangement is in order to maintain the temperature constant in the dryer and ensures a uniform air circulations in it. This is in order to enhance the drying of potato slices and reduces the drying time dramatically so that the production can be more efficiently. Next one is the tray dryer of the potato chips productions. It's just similar to the tray dryer that we have conducted in the experiment. However, before entering the tray dryer process, the potato chips are going through the wet slices of the potatoes are gone through the conveyor, which will remove some water on it through vibration. Then go on, it will enter the tray dryer, which the sensor will sense the air humidity and the air temperature around the wet slices, and therefore they will control the electric heater and the velocity of the blower fan in order to produce an optimum product. Why do we need drying in the production of potato chips and production of some food? This is because that through drying process, food can be preserved longer and with lesser moisture content. Tray dryer can remove most moisture without changing the potato slices shape or structure. Therefore, tray dryer is very useful and chosen in this process other than others dryer. Furthermore, preventing breakage is also one of the primary goals that why manufacturer of potato chips choose tray dryer as the main dryer machine. Furthermore, tray dryer is easy to control and high efficiency in the production. Next one, I will explain on the result and analysis of the experiment that we have conducted previously. From experiment A is the effect of air temperature, and the experiment B is the effect of air velocity. Based on the experiment A, which is the effect of air temperature with the constant air velocity, the heater power A is chosen, which is a lower heater power compared to another heater power, which is heater power B, and the air velocity here is 39.0 cm per second. We can see that comparing these two experiments, the rate of the drying rate is higher in the heater power control of B comparing to heater power control of A. It's actually lower, and the time taken for the drying is actually 10 minutes for the heater power of B, 20 minutes for heater power of A. However, there's some errors in the moisture content versus time graph of heater power of A, which it shouldn't be like this, it should be slowly decreasing. However, there's some errors, maybe some errors we did during the weighing process, therefore there's some mistake on it. By comparing these two experiments, we can conclude that the time taken for the heater power of B is actually much more shorter comparing to heater power of A, and the drying rate is much more higher in the heater power of B than the heater power of A. Follow on the experiment on the effect of air velocity, which is remaining constant of the heater power of B. The air velocity is manipulated by controlling the fan control on the experiment. The first one is the fan control which is 1, which is slower, 13.3 cm per second on average air velocity. The second one is fan control 2, which is 39.0 cm per second, which is higher air velocity. By comparing these two experiments, we can see that it's also the same, that the rate of drying is higher comparing to the first experiment. The higher drying rate for the second experiment shows that when the fan air velocity is higher, therefore the drying rate will be higher and the time taken for the drying will also be slower. Therefore, we can conclude that with a higher air velocity, the rate of drying will be higher and the time taken for drying will be shorter. Follow on, the result and data we are taken from is actually calculated through this formula, which is Xe, which is the moisture content, which is the weight of liquid divided by the weight of dry sand. And the drying rate we are using are actually the moisture content divided by the time. This is the end of my part. That's all. Thank you.
Hi, I'm Kiren again. So I'll be presenting on the safety and other consideration. So in a power plant, there's a lot of safety that meant to be considered. So some important steps that are necessary to be taken into consideration while in the plant or while performing the process would be prerequisite program. This PLP is implemented in accordance with Codex General Principles of Food Hygiene and Good Manufacturing Practice to establish basic conditions that are suitable for the production and handling of all safe food at all stages of the food chain. And next, the location of the plant. And the location of the plant is quite crucial because there shouldn't be threat to food safety and is away from environmental polluted areas and industrial activities, has sufficient safeguard against flooding, not prone to infestation of pests. Next, premises and room. So the premises are designed in such a manner that permits good food hygiene practices and protect good cross-contamination. So the walls are water, insects and rodent proof. Walls, angles, corner and junction of walls and floor are sealed and rounded to facilitate cleaning. The floor of the production area is established with the covered drain for liquid to drain and the netted doors are inside auto-closing. There are also floor drains 15 cm deep and directly connected to the ETP plant. The floor is epoxy and at a certain height of wall is covered with epoxy for easy cleaning. The doors and windows are made for glass covered with finished aluminum structure and 6 exhaust fans maintain fresh airflow which reduce heat vapor and thus maintain relative humidity and temperature. Next is the equipment. The equipment is stainless steel and other materials that are suitable for food industry and design construction is easily maintainable. All equipments are checked routinely to ensure a smooth running system and free of crack, rust and dents. Alright, next is waste management. So the company needs to have its own waste management treatment plant along with proper drainage and storage system, which is combination of activated sludge method and aerobic treatment that contains equalization tank, gravity settle unit, flocculation unit, coagulation unit, cube settler, effluent discharge and sand bath. So the physical, chemical and biological specification based on national standard of entering waste and discharging system is also checked regularly. Alright, lastly is the personal hygiene. All the personnel of production, packaging and storage areas use apron, hand gloves, mask, head covering and footwear. Liquid hand wash is used before starting activities. Medical checkup of every employee is done by registered medical officers at regular interval, and any sick and injured person is not allowed to enter and work in processing areas. The dresses are properly cleaned at least a week. The personal cleanliness is monitored on regular basis before entering into processing area by human resources personnel. The same instructions are also applied for visitors. All things are properly monitored and inspected by the head of human resources, HR. Thank you.
My name is Jaspreet and I'm from Group C6. I'll explain on economic analysis. The economic cost used is mainly for 5 main requirements, which are for the building requirement, land requirement, machinery, utility and raw materials. To study this production of potato chips, we refer to a case study done by Small and Medium Enterprise Development Authority Government of Pakistan. From this case study, it is seen that for the total cost for building requirement, took up to 7,635,000 rupees, where the highest cost spent is on plant area, which took up to 3,600,000 rupees, and the lowest cost spent is on two areas, which are the generator room and air compressor room, which cost up to 2,400,000 rupees. Next, the total cost used for land requirement was around 5 million rupees. Besides that, the total amount used on machinery requirement is 9,449,705 rupees, which is much higher than the building requirement cost. For this section, the most cost spent is on frozen machinery, which costs up to 4,094,025 rupees, which is almost 50% of the total cost, and the least is used for slicing machine, which is 187,000 rupees. Moreover, the total cost used for utility is around 1,916,500 rupees, where the maximum cost used is on fitting and installation, which is 740,000 rupees, and the least cost spent is on furniture and fixtures, which is 526,000 rupees. For the raw materials, the maximum cost spent is on the flavoring, which is 248 rupees per kg, and the least cost spent is on the salt, which is 14 rupees per kg. That is all from me. Thank you.
Hi everyone, my name is Didar and I'm from Group C6, and I'm here today to present you about product and the loss and profit analysis. So talking about the product, if we look at potato chip snacking around the world, it can be assumed that consumer snacking habits tend to vary depending on residence area, more precisely across different countries and cultures. In the bar chart that is shown here, you can see a clear example of potato chips consumption across the world. 86% of the world population of USA, which is up here, are ardent potato chips consumers, and the same percentage goes for the France, which is taking the first place with USA. And the leaders are closely followed by 84% of British population. However, the lowest percentage is for Chinese market, with only 28% of consumers. Generally, potato chips are sold to the public in relatively small quantities for consumption. In other words, this product is one of the most desired in the retail snacking branch. Obviously, the main raw material is potatoes. When the harvest is done, the main production procedure includes sorting, washing, peeling, trimming, and cutting into thin slices, whereupon they are washed once again and dried, and then baked until they take a crunchy consistency. As a rule, potato chips are slightly salted. However, nowadays there is a large number of different flavors available in order to move towards the refinement of a basic potato chip. From the graph here, you can see that Lay's company was ranked as the leading potato chip brand in the United States in 2015. However, Ruffles was the third ranked potato chip brand with about $521 million worth of sales in 2015. On this slide, you can see the approximate prices for potato chip products. Normally, 50% of the production will be flavored with salt, while the remaining 50% will have other flavors. In this table, approximate brand potato chips prices are shown depending on different packet sizes. In this way, if you want to buy 120 grams packet size, you should pay $3 US. For the next slide, according to SMEDA, the total project cost for setting up a typical potato chip producing plant is estimated as $624 million US. The project is financed through 50% debt and 50% equity. The project net presence value is around $2 million US, with an internal rate return of 45% and payback period of 4 years. The overall production capacity of the plant is 150 kg potato chips per hour. The plant will work in 2 shifts and operate at 50% capacity in the first year. The maximum capacity attained is 95%, and the plant operates at this capacity 6 years onwards. Thank you.
Hello, I'm Jaspreet. Nowadays, a lot of manufacturing plants use tray dryers to do separation process. It is literally defined as a process applied to remove moisture content from the substance that contain it. From the experiment conducted, we found that drying rate increases as the velocity and temperature increases. As a conclusion, the demand of potato chips increased day by day since the world population growth is also increasing. Thus, it's a very profit-motivated business. That is all from us. Thank you.